Welcome to MRL. In this learning session, we'll be studying about a few important theorems on areas of parallelograms. Now, in the present theorem, as shown in the figure there, the theorem states if a triangle and a parallelogram stand on the same base and between the same parallels, then the area of triangle is equal to 1/2 of the area of parallelogram. Now, what is the meaning of this statement? Now we have two lines L and M which are parallel to each other. We have a triangle ABC and parallelogram PBCQ standing on the same base and between the same two parallel lines. Now we have to prove that triangle ABC, the area of triangle ABC is 1/2 of the area of the parallelogram PBCQ. So that is what we have to prove. That means this is also a theorem which establishes a relation or a formula to find out the area of a triangle, that is half into base into height. So let us see how we can prove it. Given L is parallel to M, it is given to us. Triangle ABC and parallelogram PBCQ are standing on the same base and between the same two parallel lines. Now we have to prove that area of triangle ABC is equal to half the area of the parallelogram PBCQ. That means we know that area of a parallelogram is base into height. So therefore area of triangle ABC is equal to half into base into height, which is the formula for finding out the area of any triangle. Now to prove this, let us go for a construction. Now draw CD parallel to BA. Draw CD parallel to BA. Now by that we get one more parallelogram ABCD. Now let us see how to prove it. Now parallelogram ABCD, in parallelogram ABCD, AC is the diagonal and the diagonal divides the parallelogram ABCD into two congruent triangles, that is triangle ABC and triangle DCA are congruent triangles, their areas are equal, and therefore the area of the triangle ABC is 1/2 of the parallelogram ABCD. But we also observe that the parallelogram ABCD and parallelogram PBCQ are standing on the same base and between the same two parallel lines. Therefore their areas are equal. That means area of parallelogram ABCD is equal to the area of parallelogram PBCQ. That means the area of triangle ABC is also equal to the half the area of the parallelogram PBCQ. That is what is the proof of the theorem. Please remember that. Now let us go to the next theorem. Now the theorem states that triangles on the same base and between the same parallels are equal in area. What is the meaning of that? Now we have two lines L and M which are parallel to each other. We have a triangle ABC and a triangle DBC. They are standing on the same base and between the same two parallel lines L and M. Now we have to prove that the areas of triangle ABC and area of triangle DBC are equal. Now let us see how to prove it. Now we are given L is parallel to M. Triangle ABC and triangle DBC are two triangles standing on the same base BC and between the same two parallel lines L and M. Now we have to prove that area of triangle ABC is equal to area of triangle DBC. Now we have to do a few constructions here. So now draw CP parallel to BA and CQ parallel to BD. Now we form two parallelograms. One is parallelogram ABCP and the other one is DBCQ, and these two parallelograms which are formed stand on the same base BC and between the same two parallel lines L and M. That means the area of the parallelogram ABCP and DBCQ are equal because they are standing on the same base and between the same two parallel lines. Now if you observe carefully that triangle ABC is the diagonal, ABC is the triangle which is congruent to triangle PCA, two triangles are congruent here. Therefore area of triangle ABC is 1/2 of the parallelogram ABCP, and so also CD is diagonal of the parallelogram DBCQ, and therefore area of triangle DBC is 1/2 of the area of the parallelogram DBCQ. but the two areas of the two parallelograms are equal, and therefore the areas of the two triangles ABC and DBC are also equal. So that is what is the proof of this theorem, and that is what I have written here. So go through this, what I have written and whatever I have explained it to you, and you will understand it very clearly as to how to prove this theorem. So now the theorem is very clear. When triangles stand on the same base and between the same parallel lines, between the same two parallel lines, then the areas of the two triangles are equal. Please remember that. Now going to the next theorem, the theorem states that triangles on equal bases and between the same parallels are equal in area. Now what is the meaning of that? We have two parallel lines L and M, that is the line L and M are parallel to each other. We have a triangle ABC and a triangle PQR, both are standing on equal bases, that is BC and QR, that means BC is equal to QR. Now we have to prove that the area of triangle ABC and triangle PQR are equal. So let us understand how to prove it. Now given L is parallel to M, triangle ABC and triangle PQR are on equal bases and between the same parallel lines L and M, that means BC is equal to QR. Now to prove that area of triangle ABC is equal to area of triangle PQR. Now draw AM perpendicular to BC and PN perpendicular to QR. Now area of triangle ABC is equal to half into base into height, that is half into BC into AM. So also the area of triangle PQR is equal to half into base into height, that is equal to half into QR into PN. Now we know that BC is equal to QR and AM is equal to PN because it is the perpendicular distance between two parallel lines. Therefore RHS of 1 and 2 are equal. If RHS of 1 and 2 are equal, then we can equate the LHS. That means area of triangle ABC is equal to area of triangle PQR. So that is what is the theorem. So triangles on equal basis and between the same parallel lines are equal in area. Remember that. This is a very important theorem for us to remember.